Good morning friends. Today we can see antigen antibody reactions. Antigen antibody reaction, it is the interaction between antigen and antibody. It forms the basis of humoral and cell mediated immune response. Antigen antibody reactions occurring in vitro are called serological reactions. The main features: antigen antibody reactions are highly specific. It is similar to lock and key mechanism. Reaction is between the epitope of antigen and the paratope of antibody. Reaction involves three stages: formation of antigen-antibody complex, visible events such as agglutination and precipitation, neutralization of antigen. The combination it is made firm by following intermolecular forces, that is electrostatic forces, hydrogen bonding, hydrophobic interactions and van der Waals forces. Intensity of attraction between antigen and antibody is affinity. The strength of bond formed between antigen and antibody is called avidity. The phenomenon of giving extra strength to antigen-antibody complex is called bonus effect. An antibody titer, it is the highest dilution of serum which shows a visible reaction with an antigen. These are the main antigen-antibody reactions: precipitation, agglutination, complement fixation test, neutralization, and tracer techniques, mainly immunofluorescence, RIA, and ELISA. First we can see precipitation reaction. In precipitation reaction, soluble antigen combines with an antibody to form antigen-antibody complex, and the reaction it is occurring in the presence of a suitable electrolyte at adequate temperature and pH. The complex may be an insoluble precipitate, or sometimes they form suspended floccules. Zone phenomenon. Take some test tubes with equal amount of antibody. Add increasing quantity of antigen to the test tubes. In the preceding tubes, the antibody will be excess and the precipitation will be weak. Similarly, in the last tubes, antigen will be in excess, so the precipitation will be weak. For a given antigen-antibody system, the optimal or equivalent concentration of antigen and antibody show a visible reaction. If the amount of precipitate in tubes is plotted on a graph, the resulting curve will show three zones: pro-zone, zone of equivalence, and post-zone. This is a precipitation curve obtained. In this curve, we can see three zones, that is zone of antibody excess, zone of equivalence, and zone of antigen excess. That is, in zone of antibody excess, we can see the number of antibody, it is more when compared to antigen. At the zone of equivalence, the number of antibody is equal to number of antigens, so precipitation will be formed. Then, in the zone of antigen excess, the number of antigens, they are more when compared to the antibody. Next is lattice hypothesis. Marak proposed this hypothesis in 1934. This also states that multivalent antigens combine with bivalent antibody to form large lattice only at the zone of equivalence. Here we can see region of antibody excess. Here there is no lattice formation. At the region of antigen excess also no lattice formation, but lattice formation is obtained at the zone of equivalence. Applications of precipitation reaction. Ring test. Ring test, it is done in tubes, and in the tubes we can see a ring of precipitate formed at the junction of antigen and antibody solution. It is used for grouping of streptococci by Lancefield technique. Slide flocculation test. A drop of antigen and antiserum are placed on a slide. Mixed by rotation or shaking, floccules will be formed, and example is VDRL test for syphilis. Third one is tube test. This is done in tubes and is used for quantitative estimation of antibody. Kahn test for syphilis. Immunodiffusion. Immunodiffusion is also a type of precipitation reaction. The specialty is that precipitation it is occurring in gel. Here the reaction is visible as distinct bands and is stable and can be preserved by staining. This is done in 1% soft agar gel. The different types are single diffusion in one dimension, double diffusion in one dimension, single diffusion in two dimension, double diffusion in two dimension, immunoelectrophoresis and electroimmunodiffusion. First one is single diffusion in one dimension, or it is also known as Odin procedure. It is done in test tubes. In the test tube, first the antibody incorporated in agar gel is added into the test tube. At the top of this we are adding the antigen. That is, at first antibody incorporated gel is added into the test tube, antigen it is layered on the top, and after that on incubation this antigen it will move downwards to form a line of precipitation at the zone of equivalence. Double diffusion in one dimension. Here it is also known as Oakley-Falthoff procedure. Here antibody incorporated in the gel it is added into the test tube. On the top of this a column of plain agar is placed. On the top of plain agar antigen is added. After on incubation this antigen and antibody they diffuse in opposite direction to form a precipitation line, and the precipitation line can be seen in the plain agar, and it is formed at the optimum concentration. Next is single diffusion in two dimension. It is also known as radial immunodiffusion. Here antibody is incorporated in a gel and is poured on a slide. This is a slide, and in the slide wells are cut. These are the wells. These yellow colored rings are the wells, and using a well punch then an antigen is added to the wells, and antigen diffuses radially from the wells and they form a ring shaped precipitation or halo. Ring shaped precipitation or halo. This is the ring shaped precipitation, and the diameter of the halo gives the concentration of antigen. This is used for some viral infection diagnosis. Double diffusion in two dimension. This is widely employed to compare antigens and antibodies. Here agar gel is poured on a slide and the wells are cut. Antibody is placed in the central wells. Then antigens to be compared they are placed in the surrounding wells. After that they are incubated. On incubation we can see three patterns of precipitation. First one is if the two antigens are identical, precipitation lines will fuse. Here the precipitation lines will fuse because the two antigens are identical. In the second case, if the two antigens are partially identical, the two lines they will fuse to form a Y-shaped structure or spur. Spur formation occurs. And in the third case, if the two antigens are non-identical, the precipitation lines they fuse and form a cross. Next one is immunoelectrophoresis. It was developed by Graber and Williams. This is performed on soft agar gel on a slide. Here, antigen well and antibody trough are cut in the agar gel. This is the well for antigen and this is the trough for antisera. After that, the test antigen is added into the well and electrophoresis is carried out for 1 hour so that the different proteins or different antigens in the antigen mixture get separated. That is, individual antigens get separated on electrophoresis. After that, antibody is added into this trough, then incubated. On incubation, this antigen and antibody they combine at optimum concentration to form precipitation lines or precipitation arcs, and these precipitation arcs can be photographed and the slides can be stained and preserved for future use. Next is electroimmunodiffusion. This is immunodiffusion occurring with the help of electric current. Antigen antibody diffuse to form precipitin line, and this is more faster. First one is counter immunoelectrophoresis. This involves simultaneous electrophoresis of antigen antibody in the gel resulting in the formation of precipitation lines. Here again in the gel two wells are cut, antigen well and an antibody well. Antigen and antibody are added, then electric current is applied so that the antigen and antibody diffuse through the gel, and at the optimum concentration they form precipitation line. This is used for detecting antigens. Second one is rocket immunoelectrophoresis. This is used for quantitative estimation of antigen. Here antibody is incorporated in this gel and wells are cut. These yellow colored rings are the wells, and antigen in increasing concentration is placed in the wells. Then electrophoresis is carried out to form precipitation. Here precipitation arcs are formed, and these arcs or precipitation lines, they are similar to rocket, or it resembles a rocket, so it is called rocket electrophoresis. Thank you.